Hi, my name is Nick. I am career data engineer, and I am, like many of you, is fascinated by latest AI and ML trend. There are many useful tools available that are powered by AI. What I'm trying to do is to replicate one of these tools and to show that just because it's AI based, it's not necessarily out of reach for most of us. The goal is to pick one of these tools and replicate the functionality, well, at least on the basic level. We don't really want to do all these bells and whistles of the commercial tool, but we want to make sure that we can do something like this on the basic level. So let's pick one. For example, let's pick a tool called WonderChat. What they do is essentially taking a pre-trained ChatGPT model, take the content available by the business owner, and further train that pre-trained model with that content, expanding the model, then making that model available to the end users, thus presenting that information in a natural way. And the idea of that business, and I'm reading from their website, build ChatGPT powered bots from your links and files, embed on your website, boost sales conversion, reduce up to 70% of support queries, provide instant 24/7 support. So that's the whole idea. The goal is not to completely eliminate customer support, but bulk of inquiries will be supported by this LLM chatbot. As I mentioned before, we will not try to make everything they offer, and they seems pretty cool tool. They provide the users point and click functionality to create those bots with minimal technical knowledge. We're not going to be any of that, and instead we'll declare our success criteria as our bot has to be able to accept free-form queries and provide meaningful related to the knowledge base answer, and our bot should only be able to provide answers within the knowledge base context. So we're not trying to rebuild ChatGPT, available currently publicly or through the website, where you can pretty much ask anything and get any response back. We only want the knowledge to be very specific to the trained context. Just for disclosure and transparency, I have to mention that I am in no way affiliated with WonderChat. I have no relationship whatsoever with the company, and I picked it up that product randomly. I just thought it's a cool product, and I would give a shot at it, rebuilding it on a basic level. So I can divide this project in logically, I guess, 3 steps. First, we need to set up our pre-trained ChatGPT model. We're gonna base it on GPT 4.0 mini. This will provide us good reasoning capability. It's quick and also cost efficient. That's all we want. We don't want to spend a ton of money on it. Then we're gonna build our knowledge base. For those who know me, I am big fan of loyalty points, loyalty miles, rewards, everything around the game. And so I'll take blog part of my website, pointscrowd.com. So this way we can have a kind of a real example. And the last one, we're gonna wrap this application as a service available through API. And so pointscrowd.com can make inference queries to it and get responses. And this way we can integrate it. All right. So the first step, we need to set up LLM model. That's fairly straightforward. All we have to do is create developer's account with OpenAI, generate API key, install some dependencies, and we are good to go. The second step is building our knowledge base. this will be a little bit more involved. Well, let's start with how we're gonna store our data. We can really use relational or non-relational databases because the paradigm behind these data solutions can expect the patterns, access patterns from the users, and the whole goal of what we're trying to build is to accommodate queries that are free form. So we can really expect certain patterns. Luckily for us, there is another data solution. We can use vector store. The way it works, we're gonna load documents in the vector store, and the document will get tokenized instead of being stored as a text. And then when we send a query, which will be tokenized as well, and compare it with the documents against documents stored in the vector store, and probabilistically will be matched and returned by the similarity, most similar first, and so on and so on. So that should be our solution. We're gonna pick technology developed by Meta, FAISS, FAISS. It has fairly good support and documentation, and I think currently it's the best choice, although I might be wrong. So let's start with installing dependencies. So first we're gonna go ahead and install LangChain library. We're gonna install tokenizer. We're gonna install FAISS. We're gonna store LangChain. LangChain. Yep. Okay. Now let's install LangChain OpenAI. Excellent. Let's install TikToken. That is a library that will help us tokenize our content. Some of this already installed because I was doing that before the video, but you shouldn't have. You should be able to follow. We need to install FAISS CPU. Okay. FAISS has two versions, one for CPU and another for GPU. Depending on what system you run, pick the one which works for you. Done that. Now let's create a Jupyter notebook. Let's call it train. Okay, let's start. We will start with importing our libraries, our dependencies, or our libraries that we just installed. We will start with importing our libraries. Now, when we imported necessary libraries, let's set up credentials for ChatGPT. There are several ways to do this. We can pass API key directly to functions, or we can set it up as environment variable and have it that way. So we're gonna go doing just that. Set up your key here. The key will start as sk dash. Put your key here and run execute, then your code gonna work. Let's do this. Now, what we're gonna have to do, I've already collected the articles from pointscrowd.com, so we're not gonna be doing scraping here. So let's import the data. So articles folder equals path. We're gonna declare path here. It's gonna be pointscrown.com. We don't need / here. Documents. let's prepare. So we're gonna have our documents as an array. We don't need that, so we're gonna do for file path in article folder .r club, and we're gonna be interested in txt files. That looks correct, except we can't just append content, and the content has to be an object. Okay, so this has to be actual document object we imported earlier. Yep, page content. We're not gonna be setting up metadata explicitly. Instead, we just push the page content only. Okay, that's it. So we run this. So we should have documents. Yep. So these are our documents already loaded as a document object. So this is the basis for our vector store, which we about to populate. All right, and here's this is how we do it. We call it db FAISS dot from documents. Then we pass our documents, and we pass, and since we don't really save text as just flat text, and we need to pass tokenized embedding, we're gonna use OpenAI embeddings. We already use OpenAI pre-trained model, so we're gonna use OpenAI embeddings as well. Now for us, so we won't need to redo this every time. What we can do instead, we can save our vector store, our data, locally. For that, we're gonna do dp.saveLocal, and then we're gonna call it model. And as a result, it will produce two files, so, index.faiss and index.pickle. Okay, so let's create that. And here we go. Yep, all good. Okay. Okay, now we have saved data in our doc store, and now we need to set up retriever, which essentially will process our queries. Retriever db as retriever. And now let's set up our LLM. ChatGPT. Yes, except the model not gonna be ChatGPT 3.5. We're gonna use 4.0-mini. And that's, as of today, I believe that's the latest among most efficient models. So it's a best balance between reasoning versus speed versus cost at that point. And temperature is the value of how much the model can deviate from the data. So essentially, higher the number, the more creative model gets. This is not something we want, as one of the acceptance criteria we defined earlier was our model has to stick to the data we already have and not come up with any creative additions to it. So we don't want no hallucination, no creativity outside of the data, outside of the knowledge base we provided. Thus we have temperature 0. The next step we need to create, let's run this. Next step we need to set up actual retrieval. So QA retrieval QA, that's gonna be from chain type LLM. Yeah, that's pretty good, except here we already defined our retriever, so we don't really need, yeah, we can refer to it. Okay, let's run this. Okay, so now we're actually ready to send our first query and see if we have any level of success. Exciting part. So let's see what our query would be. Pointscrow.com is about the loyalty points, miles, hotels, airlines, and so on. So let's try to ask, what's the fastest way, of course, way to achieve Marriott Bonvoy Elite status. So usually to achieve elite status in any of the loyalty programs, you have to be active user, or if it's hotel, you have to stay actual nights with them, or if you fly, you have if you have a loyalty program with the airlines, then you have to fly with them. But let's ask if there is a way to become an elite member without staying in a hotel. Response. Oi. No, that's not what we want. QA.invoke, and we're gonna pass our query. And when we get the response, we want to print response, but we need only to print the result from response. There you go. So let's see what's gonna happen. What kind of response we're gonna get. Okay, great, we got response. And the fastest way to achieve Marriott Elite status is to take advantage of credit card benefits that offer automatic Elite status. So we ask if there is a way to achieve Elite status without staying in the hotel, and it tells us exactly that. We can get potentially a credit card and get the status automatically. I know that because the articles we fed to the model did have information about that. So this is spot on so far. Let's try something else. What do you know about Delta lounges? Now this time it's not gonna be just a question about knowledge I know it already possesses. We kind of confirm that it does what expected. But this time we will ask for a reference. We want to make sure our model does not hallucinate and does not come up with information not in knowledge base. So the best way to see if it will give us reference. Provide the link to the source. Well, let's see what's going to happen. Okay, Delta Lounge, known as Delta Sky Clubs, offer travelers, blah, 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 blah. For more details, or for more detailed information, you can visit the source. And here is the actual link to the blog post that has the best description according to the similarity algorithm FAISS provides on the subject. That's great. That's exactly what we want. As a matter of fact, we can ask when it was published and who is the author, and it will provide, expected to provide, let's put it this way, all this information. Okay, so this is pretty exciting. This is pretty cool. So now we have all this bunch of articles accessible by free form queries, and response we get is proper, and we know that it's actually knows and can point us to the articles if we want to examine those articles manually. So that's great. Next step is deployment. We want this inference algorithm wrapped as a service. So for the sake of this task, let's deploy it to EC2, wrap it, run it as a server, and make it accessible via API. I guess it's the quickest and simplest form. We're not going to be worrying too much. So I will take the smallest EC2 instance, which is, I believe, Nano, and it will be a Linux operating system on it. This is going to be exactly what we need. It's going to be the most cost efficient and sufficient in terms of available resources for us. I will not go over setting up that in AWS account. That's pretty straightforward. I will mention though one thing. When I created Linux instance, my instance didn't come with pre-installed Python, so I had to install Python from scratch on Linux. I won't go over this. I won't go over Python installation in this video, but I will commit instructions as a part of README file to the GitHub repo. So if you need a reference, or if you want to follow that, feel free to look it up. Okay, now we have to code the inference code, the actual code that will run on the server behind the API. Let's call it handler. We will need to import already familiar libraries. Maybe without document, we don't need that anymore, but we will need to do a retrieval QA, we will need to do embeddings OpenAI, and we will need to do FAISS so we can load our data. We're gonna make our API driven by FastAPI. So for that, we need to install FastAPI, Pydantic, and we're gonna use UVcorn server. So these are dependencies we need to add. Okay. I used a specific version of Pydantic just because I had issues for some reason using the default version. See if that's the problem for you. It might not be a problem, but just give it a shot, be aware of this. So we have to now add from FastAPI, from Pydantic. Yep, we need base model, correct. we have to declare app, FastAPI app. Then we will have to do very similar thing which we've done in the training phase. We will have to create database, which is our FAISS vector store. But now we don't have to actually retrain it. Instead, we can just load the one we saved in the training phase. So FAISS load local. Yep, that looks right, except one thing. We need to allow dangerous deserialization equals true to be able to load local. I know that this model is safe. I have nothing to worry about, but otherwise use caution. Retriever, TPS retriever. Then we have to do LLM. Yep, correct. Then we do QA. Yep. Now we have to declare our call payload. Now as we want to pass payload and get the response, we can't really use get method, so we'll have to use post method. And we want to declare a query, so our app knows how to deal with that. Oh, okay. App post, yeah, that's about right. Except maybe we don't need response part. Oh, actually, this is not gonna work for us. We need to rebuild this. So response QA invoke and it accepts dictionary, so we can pass dictionary query and gonna be request query. Okay, that should be it, and we will return response that get result. Yes, that's what we want. And now we have to add a couple of lines so our code will run at the server. Yep, that's import UVcorn, that's correct. And UVcorn run app. Yep, okay. So that's all we need here. Okay, cool. So now we need to copy this into our EC2, which we set it up. We need to copy 3 files from our local machine into EC2. One first is the model folder. Second is the handler, which is inference code. And third is requirements.txt, so we can install the requirements. Just FYI, by the time this video is released, this EC2 instance I'm working with will be removed, so I am not blurring the address of this instance because it won't exist by the time it's revealed, and I just don't want to go over entire video and blur it everywhere. So we copied model, now we copy in handler, yep, and last but not least we copy in requirements.txt. Done. Okay, so now we almost ready. I'll let you install the requirements on EC2 on your own, just like you install the Python. Otherwise, let's see. Next step, we need to log in into the server. Oh, and by the way, when you install requirements, just like in training step, set up environment variable for OpenAI API key. Once you've done this, you don't have to worry, it'll work. So now let's log in into our EC2 instance. Okay, we're there. Let's switch directory to Chatbot. Okay, we are there. Now we're gonna run the server. Okay, so it seems like our server is running. Okay, very good. So now we have to send the call and see if everything works as we expect. So let's send a test call. We're gonna send the curl call to our instance. And the first question is, what's the fastest way to achieve Marriott Bonvoy lead status? It's sort of the same. We just want to make sure that our API works and nothing has broken along the way. Okay, great. The fastest way to achieve Marriott Bonvoy lead status is to take advantage of credit card benefits. Excellent. This is what we wanted to hear. Let's try something else. This time we're gonna ask a question, and we will ask for a link to the source just to make sure there is a real article our bot references and takes knowledge from. Okay, excellent. So to quickly earn Marriott Bonvoy points, you can consider following methods, and it gives a pretty good answer, and it ends with, you can visit the source Points Crowd Marriott Bonvoy made simple, and there is a link. Excellent, exactly what we wanted. Now, one of the success criteria, as we declared at the beginning, was that the bot should not only give us data from the knowledge base, but it has to be only from the knowledge base. It has to be limited by the context of the content within the knowledge base. So let's ask the question that is not in the in those articles. And I'm fairly sure I did not include circumference of Earth in any of the articles. So let's see what's going to happen. All right, what is the circumference of Earth, we asked. Answer is, I don't know, which is exactly what we want. And if you would go on the web and ask the same question, the real ChatGPT, I'm sure it will give you very good long answer, where here it says I don't know, which is exactly what we want. The bot should not know anything about anything other than the stuff we provided and we expanded the knowledge with. All right, one thing I want to mention, it's remarkable side effect which I didn't expect to see. If you recall, I can confirm that all of the data we trained our model was in English. Every single article on Points Crowd currently in English. However, if we ask a query in different language, what's going to happen? Well, let's take a look. So this question asks a bot to tell about Marriott loyalty program, but in Ukrainian language. Let's see what's going to happen. Look at that. You will have to trust me, but it actually provides exactly the same relevant piece of information as it did before, with the only difference it's in Ukrainian. How cool is that? We trained our bot in English, and we effectively can support basically any language on the same quality level. That's just fascinating. But let's just confirm and make sure that the second acceptance criteria, that the knowledge has to be within the knowledge base and nothing outside, is included. Example with circumference of Earth still maintained when we inquiry with other than English language. The same question about area of Earth, and the answer is the same. I don't know. This is very interesting, and I think it can be a very useful bonus to the system. Unintended, albeit very useful. I hope this was useful. I hope that this was interesting. If you saw me making mistakes, please do tell. I am here to learn. If you know about better practices or better approaches, I encourage you to drop a comment or send me a direct message. I would love to hear from you. At this point, I'm going to be wrapping the video. It's way longer than I was expecting. I will save this code and push it to GitHub repo, and we'll add the link hopefully here in description or maybe in one of the comments below. As for the actual tool, as we have it now, I will make it available on pointscrowd.com. I think it's a fun idea. Hopefully will be interesting to interact and see what we get out of this. Anyone who wants to interact with this and play with this, shoot me a direct message. I'll open up a beta for you, and I would love to hear your feedback.